Doing question 5, we are given a sketch with f of x equals to 1 over 2 all to the power of x, and g of x is written in this form. We are told that B is a point on the intersection of the asymptotes of G, and A is the y-intercept of F. The graph passes through the origin. AB is parallel to the x-axis. So this is your graph, as you can see. So what you're going to first do is, in 5.1, we're going to write down the inverse of F in the form y is equals to. So f of x is given as 1 over 2 all to the power of x. So to find the inverse, we first write y is equals to 1 over 2 to the power of x. Then we swap, where there's y we put x, where there's x we put y. So it's going to be 1 over 2 to the power of y, and then we write in standard form. So it's going to be y is equals to log base 1 over 2 multiplied by x. So this is going to be our inverse of f. So now in 5.2, we are asked to write down the domain of the inverse of f. So to find the domain, we know that our inverse is y is equals to log of base 1 over 2 multiplied by x, right? So which, if you were to draw this inverse, you're going to have something like this, looking like that. And what you need to note is this is y-axis, this is the x-axis. The x values, because we wanted the domain, so we're focusing on the x values. The x values don't necessarily touch the origin, so they don't necessarily touch this. When x is equals to 0, the graph doesn't touch, because this is where the asymptote moves, right? So but anything above x is equal to 0, the graph is moving, you know, it's passing through. So we can simply say the domain, which the x values of this graph is greater than 0, because it will never touch the asymptote. So it's just going to be x greater than 0. So now in 5.3, we are asked to sketch the inverse of f, indicating all axes and asymptotes. So remember that our inverse is y is equals to log of base 1 over 2 multiplied by x. So we first have to find our x-intercept when y is equals to 0, right? So where there's y, we put 0 is equals to log of base 1 over 2 and x there. So this 1 over 2 is going to be to the power of 0 is equals to x, which is equals to 1, because anything to the power of 0 is 1. So the coordinates is 1 and 0 for our x-intercepts, and then our y-intercepts when x is equal to 0. So we have y is equals to log of base 1 over 2 multiplied by 0. So here you won't find a solution, so there's no solution. So it means that your graph does not pass through this y-intercept. So meaning that now if you are now going to draw your graph, you have your graph there, and you know that it passes through a point of x, which is 1 and 0, but it doesn't pass through your y-intercept. So this is your y-intercept, this is your x, so it's a y-axis and x-axis. So your graph is going to move like this, meaning that it won't touch your y-axis. So this is your inverse of f. 5.4, we are told that if h of x is the equation of one of the axes of symmetry of G, determine the coordinates of B. B is actually the intersection of our asymptotes, both vertical and horizontal. And so for us to find the points here, we need to first find this value of a here, right? This value of a lies in our graph of f of x, right? But remember, the previous question, we found our inverse of f, which was moving like that, and we found this point to be 1 and 0. So what this means now is our value of a is going to be the inverse of this coordinate here, so it's going to be 0 and 1. So that is our coordinates of a, right? So looking at those coordinates, it tells us that our y is actually equals to 1, right? So it's moving like this, which is our asymptote, one of the coordinates of b. So meaning that if we want b, we know that x we don't know, but we know that the value of y, which is 1, right? So it's going to be simpler now for us to find the x value of b. So having our h of x being equals to x plus 3 and our b being equals to into x and 1, so we want to find the x value now of b. So we're going to substitute this y value in our h of x. So we're going to put 1 instead of h equals to x plus 3. Transpose the 3 to the other side. We have x equals to 1 minus 3, and then x equals to minus 2. So this is the x value of our b. So if you write b, it's going to be minus 2 and 1. Now 5.5, we are asked to determine the equation of g. Remember now we have our intercept of asymptotes being minus 2 and 1. So it's going to be easier now to find our value of g. So our g of x being equals to a over x plus p plus q, and our value of b, which is the intercept of our asymptotes, minus 2 and 1. So this tells us that our vertical asymptote x is equals to minus 2, our horizontal asymptote y is equals to 1. So if we substitute in our equation of g, we have a over x plus 2 plus 1. So this is our graph, but it's not complete since we don't know the value of a. So we need to substitute a point to really find the value of a. Remember that our graph passes through a point of origin of 0 and 0. So you're going to substitute that point of 0 and 0. So it's going to be 0 is equals to our a value over 0 plus 2 plus 1. Transpose the 1 to the other side. Minus 1 equals to our a over 2. Cross multiply. So our a is equals to minus 1 times 2. So our a value is equals to minus 2. So to write down our equation, g of x is equals to minus 2 over x plus 2 plus 1. So this is our graph of g. So now we're going to do 5.6. We are asked to write down the equation of k such that k of x is equals to g of x minus 3 plus 1. So what you need to first do, you need to write our g of x, which is equals to minus 2 over x plus 2 plus 1. And we are told that our k of x is equals to g of x minus 3 plus 1. So our k of x will be equals to minus 2 over, so in our g of x, we're going to substitute this value here. So we're going to substitute it here. It's going to be x minus 3 plus the 2 plus the 1, which is this one, and we're going to plus this one, which is 1. So our k of x is going to be equals to minus 2 over x minus 1 plus 2. So this is our equation of k of x. Now we're doing 5.7. Determine the values of x, or for which 5.7.1, when the graph of f multiplies the graph of g, gives you a solution of y which is less than or equals to 0. So it gives you a solution of y which is 0 or which is basically negative, right? So we need to look at that. So when does that happen? So you go back to your graph, you look for a point where when you multiply f and your g, you get a solution that is less than or equals to 0. So we're going to look at that. So this is our graph of f, this is our graph of g. So this part of the graph the graph of f here, our y values are positive, right? Our y values are positive, going up they are positive. And then for our graph of g, our y values are negative here, going down they're negative, negative, negative. So when you multiply a positive with a negative, you get a solution of negative, right? So this is what we are looking for. We're looking for that situation where we multiply a positive and a negative, you get a negative. So this means now that we need to consider this part of the graph, but we can't consider the entire part. So if we were to consider, we'll consider this portion here of our f of x. Why? Because there's an asymptote here that is moving here of x equals to -2, right? Where it's just separating these two graphs. So we're just going to consider this portion here of f, and we're going to consider this portion here of g, so that when we multiply these two, they give us a solution of negative. So your solution of x now, you're just going to say when x is greater than -2, this positive y value multiplied by this negative y value will give me a solution that is less than or equals to 0. So this is the first solution of x, right? When x is greater than -2. Or someone can also look at it from this part of the graph, where this portion here for your g is actually positive. So your y values here are positive, going down like that, they are positive. And if we consider this portion of another solution of x would be, you need to remember that we need to make sure now that, because after this point here, so after this point, everything within this point here is correct. So if you say x is greater than 2, it's correct. But after this point, our graphs come to a positive part of y, right? So our y's both are positive, so it doesn't necessarily qualify us into finding the solution here. So means that our x values must be within the point of origin and x being greater than -2, right? So, or you can also say, or x must be less than or equals to 0. So when x is less than or equals to 0, the same happens where positive multiplied by the negative gives you a negative solution of y. So you can simply say, write down as x greater than -2, or x less than or equals to 0. Or you can simply say when x lies between -2 and 0. So both these solutions are correct. So now 5.7.2, we are asked to find solutions of x when the g prime of x is greater than 0. So what this means now is we want to know the values of x when the gradient of the g of x is positive, it's increasing. So this is our g of x, right? And this is also our g of x, right? So let's look at how it's moving. So our g of x is moving from the left to the right, right? So it's actually increasing. So the gradient is positive. Why? Because it's increasing. It's increasing from here, and it's separated by this asymptote here of x is equals to -2, right? So our graph is increasing. Even here, our graph is increasing from the left to the right hand side. Our graph is increasing. So how do we find the solutions of x when the g prime of x is greater than 0? So this means now that when x it's less than -2, which when it's less than this asymptote of x is equals to -2, our graph is increasing, as you can see there. Or when x is greater than -2, our graph is still increasing, right? So those are the solutions of x. When x is less than -2, our graph is increasing, or when x is greater than -2, our graph is increasing. So these are the solutions that we are looking for. Or someone can just say when x is the element of real numbers, but x is not equals to -2. So these two solutions are considered. Either you write this or you write these two here.